door, please. All right, we are going to start off with this example from yesterday. Are we all ready? I think we did this, but it'll be a nice review and to go into what we need to go into, okay? So x cubed minus 5x. What's the very first thing we need to do with this problem? We need to graph it. So, anybody tell me what that was again? X cubed minus 5x. So I hit enter. All right, so there's my graph. The very first thing, whenever you look at this, I want you to think about, is this function even or is this function odd? How do I determine that? If it is an even function, I should be able to focus over the y-axis and it lay directly on top of the other function. So is this even? No. So if I'm odd, then I should be able to fold it hot dog over the y-axis and then hamburg over the x-axis, and then it should lie directly on top of each other. Is there a potential for this to be an odd function? Yes. So what this means is whenever we go to check our work algebraically, we are going to do f at negative x and check to see if it equals negative f of x, because our gut instinct tells us that this is going to be an odd function. Remember, that's what we talked about yesterday. Okay, so in order to do this problem, what do I have to first find? I need to find our relative max and mins, right? We need to find where this thing is going to be at the highest and where this thing is going to be at the lowest. So remember I told you to put yourself onto this lovely graph from left to right as if you were doing a roller coaster, right? So the very first thing I want to do is I want to hit menu, analyze graph, and I want to do our maximum value. So we're going to go to the left of our maximum value and hit enter. We're going to go to the right of our maximum value and hit enter. And do we see that we get the point negative 1.29 and 4.3? Okay, what is that point just understood to be for us? What is that? Did you sign in? Yeah. Okay. So this is going to be our lovely little maximum. So if this is our maximum at negative 1.29, and what was it, 4.3? Should have been. So we're going to come back over here and we're going to do our minimum value. So menu, analyze graph, and we want to do minimum this time. Go to the left of the valley, hit enter, go to the right of the valley, and hit enter. And this time, what am I going to have? 1.29 negative 4.3. So I come back over here and I'm going to write that down. 1.29 comma negative 4.3. Do we see that? Yes or no? Okay. Now, another great way to check if you are even or odd, if I am an odd function, my point in quadrant 2, if I look diagonally, will be exactly the same point in quadrant 4, except for the x and the y will both change. So my x in quadrant 2 was negative 1.29, and now it's positive 1.29. My y in quadrant 2 was 4.3, and then it changed to negative 4.3. So this means that this is a very, very, very strong possibility that this is going to be an odd function, because not only did I see that it was going to be symmetrical over across the origin, it also has my ordered pairs being opposite completely. Do we understand that? Okay. Now, can anybody tell me what the domain of this function is? How do we read our domain? From left to right. So what is my domain? Notice it goes on forever in both directions. So I would technically have an arrow on the bottom and I'd have an arrow on the top here. So this is going to look like my cubic function. So my domain is going to be negative infinity to positive infinity. Very good. And my range, I read it from bottom to top, and we also know that's going to go from negative infinity to positive infinity, right? Now I want to know, where's it decreasing, increasing, and constant, and how do we read this? From left to right. So as I am approaching my function at negative infinity, what are my y values doing? They're going up. So at negative infinity, I am increasing. And where do I stop increasing? At what x value do I stop increasing? I'm going to stop increasing whenever I get to the top of this mountain right here at negative 1.29 x value, correct? So I come over here and I'm going to stop increasing at negative 1.29. Then what happens at negative 1.29? it starts to decrease and it goes down the mountain until what valley point? Positive 1.29. Oopsie. Okay, so I'm decreasing from negative 1.29 to comma 1.29. And then what happens at 1.29 again? We can see it starts to increase to where? Infinity. So I'm going to go ahead and I'm going to put a U here so that you know that it's increasing again, and it starts at 1.29 and it goes all the way to infinity. Now, do I have any constant terms here or constant values? So do I leave it blank? No, I have to acknowledge that, and I have to put the word none there so that I know that I see no values that are constant in this function. Do we all understand that? Okay, now, we have our gut instinct is telling us that this function is going to be an odd function. In order to say that I'm an odd function algebraically, I have to go ahead and prove, if I am odd, that f at negative x is equal to negative f of x. Do we understand that? That's what it means to be an odd function. So if that's the case, I have to do f at negative x. So every place I see an x in my function, I'm going to replace it with what value? So this is going to become a negative x cubed. What was that, minus or plus, y'all? Minus 5 times a negative x. Do we see that, yes or no? What is a negative x times a negative x times a negative x? Come on, cubed. So this is going to be negative x cubed. And what's negative 5 times negative x? Positive 5x. So this is what I calculated for f at negative x. It's actually going to be negative x cubed plus 5x. Do we all understand that? Okay, now what I need to do is I need to calculate negative times f of x. And negative times f of x is just negative 1 times f of x. Do we all understand that? So I'm going to take my function, I'm going to distribute a negative into it. My original function was x cubed minus 5x. Would you agree? So all I'm going to do is distribute the negative, negative x cubed plus 5x. Now here's my question. Are my two boxes equal to one another? Since my two boxes are equal, the first red box is f at negative x, and the green box is going to be a negative distributed into f of x. Since they are equal to each other, I've proven that this is an odd function. So we knew it algebraically, I should say, we knew it graphically by looking at the symmetry and reflecting it over the x-axis and the y-axis. We knew it by looking at the ordered pairs diagonally, that they both changed. And now we know it by algebraically checking it as well. Do we all understand that? We good? Okay, so how do I prove that this function right here is indeed even or odd without graphing it? I'm not going to graph the function, so I have to prove even or odd algebraically. So how do I go about doing that? I have to literally do f at negative x. So f at negative x is going to be 3 parentheses negative x squared minus 2. What is negative x times negative x? X squared. So this becomes 3x squared minus 2. Box that in. Now here's my question. In order to be even, f of x equals f at negative x. To be odd, f at negative x equals negative f of x. Now, are my f of x and my f at negative x equal? Yes, they are. They're exactly the same. My original function, which is right here in black, is equal to my blue function, which is f at negative x. So what did I just prove about this function? That is an even function. If I'm an even function, what do I know about my even function symmetrically? No. What do I know about the symmetry of my even function? It reflects over the y-axis. So if I fold it over the y-axis, both sides of the graph will lie directly on top of each other. Do we understand that? Okay, let's do another one. X cubed minus 1. All right, now let's think about x cubed. And actually, let's go back to this for a second. This right here is 3x squared. 3x squared minus 2. X squared is what type of a function? What does x squared look like? Okay, make sure that we remember our parent functions. y equals mx plus b. That's our line, right? Oh, I drew backwards. That's your line. Y equals x squared. That's your u. Y equals x cubed. That's your spaghetti. Y equals absolute value of x. That's the v. Y is equal to the square root of x. That's the one-armed bandit. Do you remember those? Like, you have got to commit those to memory. We talked about that yesterday. I made you guys write them all down. Yes? Okay? So whenever we look back at this one anyway, we know that the 3 stretches it. Yes? Stretch up, down, left, right, stretch, compress, reflect. We did that a ton last year. Okay? This -2 pulls it down and actually gets to be a little bit more narrow. It becomes a travel mug. Remember we talked about that last year? Okay? So if I were to fold that directly over the y-axis, do they lay directly on top of each other? It sure does. Okay. Well, now let's take a look at this function. I give you x cubed minus 1. I'm going to box this function in because that is f of x. Okay? Now, what does x cubed minus 1 look like? What's x cubed look like? Nope, nope, nope. Put that calculator down. It looks like spaghetti. So if this is x cubed, spaghetti function of x cubed minus 1 means what am I doing to the graph? I'm shifting it down 1 unit. So I'm literally shifting it down 1 unit. Do we see that? Yes or no? Yes? Okay. So my question to you is, does this look like it's even, odd, or neither? I don't know. Is it going to be even? No. Could it be odd? It could be, but we don't know until we check. So what you think it probably is going to be odd. So if you're thinking it's odd, that means you want to check if f of negative x is equal to negative f of x. So I'm going to go ahead and I'm going to do f of negative x. Every place I see an x, I'm going to replace it with a negative x. A negative times a negative times a negative is a negative x cubed. Minus 1. Okay, so there's the first one. I can check my philosophy about even. Are my black box of my original function f of x equal to f at negative x? Nope, it is definitely not even. Okay, so now I'm going to come over here and I'm going to do negative times f of x. So that's going to be a negative times x cubed minus 1. So that's negative x cubed plus 1. Are my red and blue boxes the same? No. So is it odd? So what do we have now? This is a neither function, meaning you thought it could be odd because it had the potential to be, but because you shifted the graph down 1 unit, it no longer holds that symmetrical property of being symmetrical according to the origin. Do we all understand that? Being symmetrical to the origin means you're folding it hot dog and hamburger style over the y and x axis. Yes? Okay. This is just like problems from last night. 11 through 16. Do we understand that? This is just like 11 through 16. Now let's talk about ordered pairs. And these are like problems 17 through 20. Now if I give you these two ordered pair, if I give you this ordered pair and I say, hey, I have the point 1, 3. Guys, this is a point on my graph. And I'm telling you that my graph is symmetrical according to the y-axis, meaning it is an even function. If I'm an even function, I can fold this over my y-axis. Would you agree? So what will be the even function point? Excellent. -1, 3 is going to be my even function point. Do we understand that? Well, what if I wanted it to be an odd function? From the green. Nope. Remember, I said if it's odd, it goes diagonal. So it's going to be -1, -3, meaning both the x and the y coordinate change their signs. Do we all understand that? If I'm an even function, only my x changes signs. So let's try it again. I give you another point, and this point I'm going to give you is, let's say, -5 and 1. Give me the even point. 5, 1. 5, 1 is your even point. Do we all understand that? Only the x change. What's my odd point to -5, 1? 5, -1. Do we all understand that? Yes or no? That's how you do 17 through 20. All right, that brings me to my last example that I want to talk about, which is going to be graphing piecewise functions. And we did this before. We did this last year. We graphed piecewise functions. You guys did not love it, but we did it, okay? When you graph piecewise functions, basically what you're doing is you're graphing all three of these functions, but you're only graphing them between the intervals that it allows you to graph it. So 2x plus 1 will only be utilized for the values when x is smaller than or equal to 0. So how do I graph 2x plus 1? Why are we using the point 0, 1? It's the y-intercept, so I have the point 0, 1. Then what am I doing? My slope is mx plus b. My slope is 2, so I'm going to go rise up 2 units and to the right 1. Rise up 2 units to the right 1. Rise up 2 units to the right 1. Go down 2 and to the left 1. Go down 2 and to the left 1. Do you see that lovely little line is right there? Now, I have to graph that entire line, but I only want to use it when x is less than or equal to 0. Now, be careful and don't do what I do yet. Just wait. Here's my line. Do I need the whole line? No. I don't need the whole line. I'm going to shrink my line down, and I'm only going to use it when it is less than or equal to the value 0. So when x is 0, what is y? When x is 0, what is y? One more time. In the function 2x plus 1, when x is 0, what is y? Do we all understand that? So it is your y-intercept. So I do not need any of these points up here. Do we see that? Yes or no? Okay? So this is going to be our lovely little first part of the graph. The second part of the graph is going to be y equals 3. What does y equals 3 look like? Which way? I mean, it's horizontal or vertical? Always horizontal. I'm going to make you guys tell me that. So I want this horizontal line at 3. Do we all see that? However, am I going to want that to go all the way across? No. When am I utilizing y equals 3? Between the points 0 and 4. So I'm literally going to shrink this between 0 and 4. However, here's my question. Can I use that when x is 0? No. So I'm going to have an open dot at 3. At the 0, x equals 0. Yes? And can it be 4? So I'm going to have an open dot down here at the end of that for the x value 4. Do we understand that? Yes or no? Okay, it's less than 0 is less than x, which is less than 4. So it can't be used when x, I can't use 3 and evaluate this function at 3 between smaller than 0 or greater than 4. I can't. I can only use it between the values of 0.99999 all the way up to 3.99999. You with me? Okay. All right, now, the next one, x minus 5. How do I graph that? X minus 5, what do I start out with? I'm going to start at 0, negative 5. So 0, negative 5 is here, and what's my slope? Up 1 to the right 1, 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 and I just keep on going. Do we see that? So I have this graph. Yes? Do I want the whole graph? When do I use this graph? When it's greater than 4, so I am going to shrink this bad boy to the x equals 4 position. Do we all understand that? So I erase those points there. And my question to you is, can it be 4 on this problem? Yes. So I simply put a closed dot there, and then there's an arrow on this side, and there's an arrow on this side. Do we see that? Yes or no? Okay, let's do number 9. Let's do number 9. So how do I do number 9 on last night's homework? What do I do? I need to graph x plus 5. So if I'm graphing x plus 5, what am I starting off with? 0, 5. So I'm going to start at 0, 5, 1, 2, 3, 4, 5. That puts me here. And I'm going to literally do what? Up one to the right one. Everybody do that. I'm so sorry. Okay, now with that being said, we're going to go up one to the right one, up one to the right one, up one to the right one, down to the left, down to the left, down to the left. Do we see my equation? When do I utilize this equation? It's less than or equal to -3. So you know what that means? I'm going to have this lovely little line. There's my line. But I'm going to shrink this bad boy to go all the way down here to -3. Yes? So I don't need any of those dots. Are we good? Can it be -3? Yes, I need to make sure that I put a closed dot right there. Okay, then I need to graph -2. So how do I do that? What type of a line is y equals -2? Horizontal at -2. Horizontal at -2. So that puts me right here. Okay, and when do I utilize that? Between -3 and +1. So here's -3, and here's +1. Okay, here's the question of the hour. Can it be -3? It is open. Can it be +1? It is open. Okay. It's really kind of hard to see on my board there that that's open, but it is. Okay. Then the next one we're going to graph is going to be 5x minus 4. What am I starting at? 0, -4 puts me right here. And I'm going to go up 5 units into the right one. Up 5 units into the right one. Okay. So there's my graph. Yes? We all see my graph? When am I utilizing that? When it's greater than or equal to 1. So I'm going to shrink that. And here's my question for you. Can it be -1? Or can it be +1? Sorry. Yes, so I'm going to have a closed dot there. Any questions over that graph? Okay, let's do number 10. Okay, same thing. What do I graph first? There's only 2 on this one. 3 plus x. So that means I'm graphing 3 plus x. And what am I starting off with graphing? 0, 3. Correct. Very good. So I'm at 0, 3, and that puts me here. And what's my slope? Up 1 to the right one, up 1 to the right one, up 1 to the right one. Down to the left, down to the left, down to the left, down to the left. Okay? And when am I utilizing this line? When it is less than 0. So I absolutely do not need any of those red dots up top there. And can it be 0? No, so I have an open dot there. Yes? I have an open dot there. Okay? So now what? What am I going to graph next? X squared plus 1. If you have to do this, what is my vertex? Remember vertex? X minus h quantity squared plus k. Do you remember that? Remember that from algebra 2? It should be coming back. There's nothing here, so that my vertex is going to be 0, 1. So my vertex is 0, 1. And remember when we graphed these, we went up 1 to the right one, up 1 to the right one, up 1 to the left one, up 1 to the left one? Yes? Do you remember that? And so that means this is going to be my graph. Do we see that? However, when am I going to utilize this? When it's greater than or equal to 0. Do I want the left arm of this graph? I only want the right arm of this graph. So the left arm is not even necessary to be there. Now, can it be 0 there? Yes, it can, so I leave it alone, and that's my graph. Okay? I did those with you because they're kind of trickier, and every year my students don't like that problem. Okay? So, tonight for homework, you guys need to finish this worksheet up. You should be fine now. I've taught every single thing on this worksheet. You should have no problems. In addition to that, your Math Excel for section 1 through 3 is up and live. Tomorrow in class, I'm going to allow you to have class time on Thursday and Friday to do Math Excel. However, you will be retesting over sections 1.1 and 1.2 quick quizzes if you need to retest. Friday, I'll be giving the quick quiz over section 1.3. So yes, you'll have 2 days to work on Math Excel, but are you really going to have a lot of class time to work on that if you're going to be retesting? So if you are going to be retesting, you need to make sure you start working on your Math Excel now if you don't have internet while you're at school. If you do have internet, you can work on it at home. Do we all understand that? There are 18 problems. Some of them are the vertical line test, domain, range, increasing, decrease, parallel, perpendicular line, find the equation of the line. Are the lines parallel, are the lines perpendicular, or neither? Do we have any questions over what the Math Excel will be over? Okay, if I'm giving you until Friday for the Math Excel, Monday, whenever we come back, we'll be reviewing, and we will have a test over sections 1.1, 1.2, and 1.3 on Tuesday. Questions, comments, or concerns? Okay, you have 10 minutes remaining. The rest of the time is yours in class.